These are notes for section 5.2, solving linear systems by substitution and their special cases. If we remember, a linear system from previous sections is simply two lines or two linear equations in the same problem. Typically, we are looking for the point or the ordered pair where these two lines cross in order for the answer, for the solution. Well, we've picked up already that some linear systems have no solution, meaning they don't cross at all, they don't share a point in common. And some linear systems have infinitely many solutions, which means the equations or the lines are the exact same. And so both of these lines, the linear system, lie right on top of one another, and they share an infinite number of points together. So now we need to today look at how these two special cases look when we're solving them algebraically. If we remember, substitution is a pre-algebra topic. If we review real quick here, if I had the expression 3x plus 1 and x is equal to 2, well, I would simply take that 2 and plug it in for x. That's 3 times 2 plus 1. That's substitution. 6 plus 1 would give me 7. It's the very basic pre-algebra concept, but when we're talking about linear systems, it gets a little bit more challenging. So if we look at number 1 here, we are not ready to do any kind of substitution because I don't have an equation that says either x equals or y equals. But what I could do is take this top equation. I could take this x plus 5y equal 9, and I could subtract 5y to the other side. Now, the reason I want to do that is so I can get an equation that says x equals negative 5y plus 9. Now, again, if we talk or think for a moment about substitution, that's x is equal to a number, and so I can take that number and plug it in for x. Well, if I have the expression x equal negative 5y plus 9, what I can do is take this stuff that x is equal to and plug it in for x, which would make the second equation read negative 5y plus 9, because that's what x is equal to, minus 5y equal negative 9. And now I have a single variable equation. It's an algebra 1 thing we should be able to solve. To get rid of the parentheses, I distribute 5y minus 9 minus 5y equal negative 9. That's taking a negative, distributing. Combine like terms. 5y minus 5y would just be 0. So our y's are eliminated. We're left with negative 9 equal negative 9. Well, that's true. We don't have a variable left in the problem. We have a true statement. And if we have a true statement, what we would say is infinitely many solutions, which means these two lines are the exact same equation. One of them just has a negative ran through it. These two lines lie right on top of one another. They have an infinite number of points they share in common. And again, if we look at a picture, it would look like this last one over here with the red and blue. Number 2, it's already solved for y. It says y equals negative 8x, which means I take this stuff that y is equal to, and I plug it in for y. So the rest of the equation is the exact same, 24x plus 3 times, and instead of y, I'm plugging in what y is equal to, negative 8x equal negative 2. So that's 24x minus 24x equal negative 2. That's 3 times negative 8. Combine like terms, 24 minus 24, again, is 0. 0x, or just 0, nothing left. So 0 equals negative 2. Well, that's false. That's not true. 0 is not equal to negative 2. So if our variables are eliminated and we have a false statement, what we would say is no solution, which means these two lines never cross. And again, in a picture, these two lines never cross. They don't share an ordered pair in common. So those are the special cases for linear systems. We have either infinitely many solutions, meaning we have a true statement, or we have no solution, which means it's a false statement. Let me work through two more if you need some additional help. On number 3, it already says x equals. So I can take this stuff that x is equal to and plug it in for x. That would be -3 times. Again, I'm copying down all of the entire equation. The only thing that changes is what I'm substituting in. Instead of x, I have y plus 8. From here, I should be able to solve. Distribute, combine my terms, pick on the little guy, get the variable by itself. So I distribute a -3, that would be -3y, -3y minus 24. Combine like terms, -3 plus 5 is 2. And now I'm working to get y by itself. Notice my y did not eliminate. I have a y value. I'm going to end up with a y value. To get rid of a minus 24, I can add. And to get rid of a times 2, I can divide. Y equals 0. Well, if I end up with a value y equals 0, that means that these lines do cross. And I need to find the ordered pair where they cross. I have half of my answer. Half of my answer is something, comma, 0. Because y is equal to 0. Now to find the other something, as we discussed in a previous video, we need to take this y value of 0 that I just solved for, and I need to plug it back into either equation for y. I could either plug it in here, or I could plug it in up here. It doesn't matter. You'll get the same answer. I'm going to pick the equation that looks easier to solve. So x equals y plus 8. That's 0 plus 8. X equals 8. That means that these two lines cross at the ordered pair, 8, 0. Now you might say, well, how am I supposed to know if I get a special case or a point where they cross? We'll just work through the math, and if your variable is still in the problem, they cross. And again, number 3, our answer, 8, 0, would look something like this picture. These lines cross at an ordered pair, 8, 0. No solution, they don't cross, or infinitely many solutions. Last one, number 4. Again, I'm not ready to do substitution because it doesn't say x equals or y equals. But I could take this top equation and simply add 3x to the other side, so I get y equal 3x plus 8. I could take this stuff that y is equal to and plug it in for y. That's the substitution. So that's 6x minus 2. And instead of y, I'm plugging in 3x plus 8. After I do some substitution, I need to solve the equation. I solve by distributing. That's -2 times 3, -2 times 8. Distribute, combine like terms. 6 minus 6 is 0. So my variable x is eliminated. I'm left with -16 equal -7. That's not true. That's false, obviously. If my variable is gone, 6 minus 6 is 0, I don't have any more x's, and I have a false statement, I would say no solution, which means these two lines would be parallel. They don't share a point in common. Hopefully that helps. Appreciate you watching, and I'll catch you on the next one.